So I'm dropping you into a project that I started 2 weeks ago, maybe, and it started just as a casual, personal thing. It was just I feel like doing something that's not related to work. Well, I mean, it's related to what I do, but it's not for work, right? I'm not being paid to do it by someone. But I recently learned that there's a Toronto Prop Expo coming up in about just slightly over a month. Actually, no, it's probably less than a month now. Anyway, the Toronto Prop Expo is coming up June 21st. And I hadn't heard about it until just recently. And I thought, what if I were to finish K9 and bring it to the Prop Expo? That would be cool. That would be fun. So if you're a Doctor Who fan, you know exactly who this is. At least I hope you do. Otherwise, I failed completely. Doctor Who in the late 70s and early 80s had this character K9. He was this little robot dog. You can look him up if you don't know who he is. And that's one of my very early memories of TV as a kid. I was young enough that the show used to scare the crap out of me. The Daleks terrified me. But I loved the dog. I loved the dog, and I thought Lana Ward was really pretty. So I had like this childhood TV crush on Lana Ward, and I wanted to see K9 the dog. So I would watch it anyway, despite having nightmares afterward. So what I'm doing is building a replica of K9. Now I don't normally do replicas for like fanfare type stuff, so I don't know much about it. Like I don't know what's considered truly authentic or any of the sort of the unwritten rules about fandom and that sort of thing. So I'm just kind of winging it on my own. So I thought I'd bring you in now that I've turned it into a project with a specific deadline in mind. I thought I'd turn it into some content. So I'm creating K9, recreating K9, pardon me. And initially I was just going to model it up as a little statue. But, I did, of course, obviously it crossed my mind that I could motor him up and what have you. But then when I found out about the Toronto Prop Expo, I said, okay, well, obviously he has to be remote control powered and everything. So this project, scope creep, went like exponentially up on this one, and I'm into the thick of it. So I'm going to bring you in on what's done, where we are now, and then over the course of the next 3 to 4 weeks, I'll produce videos showing the progress. So where are we now? Well, obviously I've created the head. It's not quite complete. I've got some work to do yet, like some touch-up work, and the back isn't, the seams aren't filled in the back of the head, but the head is almost done, at least the exterior of the head. Obviously, he has an LED back there. All the faces are 3D printed. Basically, everything you see here is 3D printed. But then, of course, and then glued together. I didn't print them all in one shot. I printed all the separate pieces, all the separate faces as a separate piece out of PLA wood. PLA wood is so much easier to sand. And if you don't know what it is, it's PLA filament with 30%, roughly 30% wood dust mixed in. And it just sands way better than PLA does. Now, it might be, I think it's a little bit softer. I don't know that it's quite as, the surface is not quite as hard as regular PLA, but I mean, I end up, filling in stuff with body filler compound and priming and all that stuff, so I don't really care about that slight difference in hardness of the surface. So I've just connected the head to 12 volts because it's got a 12 volt LED in there. That's just temporary with a couple of wire nuts. Those will come off and it'll be a permanent connection. I've made the back as well. This is this will sit sort of on top of his back and the sides come down here. It's got LEDs in the back. It's a little sloppy, but I don't care because it's inside. No one will see, right? These are all semi-transparent filaments that I printed so that the LEDs will shine through. They're not very bright, but that's okay. What I'll do is I'll probably dedicate an LED chaser circuit so that, and then I'll wire them up in just a random sequence so that I can use the microcontroller to trigger the chaser, and then they'll just kind of go like beep, 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 something like that. I don't know. I've got some time to think about it if I come up with something better. I decided that after the show, I don't really have a need to keep him, so it's going to be for sale after the show. So end of June. If you're a Doctor Who fanatic and you want a working remote-controlled K9, hit me up. So basically what we've got is two 12-volt lithium, it's LiFePO4, Fe obviously being iron, PO4. I'm a little bit embarrassed to admit I can't remember off the top of my head what PO is. I don't know, it's phosphorus or, anyway. So they're not lithium ion, they're lithium iron PO4. But they charge off a regular, one of these regular standard battery chargers you can buy at a hardware store. Not the chargers that are only designed though for lead acid batteries, right? You have to get one that works with lithium batteries. So what I've done is I've wired them in series. So I have a minus 12, a ground, and then a plus 12. I run from ground to plus 12. I use that to power these two buck boost converters. So some buck boost converters, obviously, that's how I do my voltage regulation, as I was mentioning. So I've set 1 to 5 and 1 to 12 volts. They're just both running off of between the rails of one of the batteries. And then this, because I already had this motor controller, I'm just going to go ahead and use it. Ideally, I really probably would prefer to use a MOSFET-based motor controller. This is running on BJTs. And of course, BJTs are not as efficient. So, it's kind of the standard practice that when you're running something off battery, it makes more sense to use MOSFET-based controllers, just for their efficiency so that you're not wasting battery life. But, there's a lot of juice between these two batteries. So because I already had it, I'm not going to spend the money on a whole other controller. 12 volts I need to run, the LED on his head, and surely there'll be other stuff that I'll need before this project is over that'll run on 12 volts. The 5 volts, obviously, I need to power the microprocessor, which is an ESP32. So the ESP32 will send the pulse width modulation for the drive motor, which is a geared down, I don't have it in front of me, it's a geared down DC motor. I haven't designed the steering system yet, but I have an idea in mind on how I plan to. I did buy a little stepper motor that runs like sort of laterally, those linear ones with the worm screw in them. And that's what I plan to use to control the steering. So obviously that'll run also off the ESP32. And here's a closer look at the microcontroller. It's really just a standard ESP32. There will be a second ESP32, one of those little C3 minis. It's a small thing. It's only got about, 16 pins or something like that. That'll be in the handheld controller. So I'm just going to use, there's a protocol called ESP2 Now, or ESP Now, I think it's called. It allows ESP32s and the older ESP 268 or 286 or whatever, the older ones, I forget. Anyway, the previous generation from Expressive. It allows the MCUs to connect directly to each other and communicate wirelessly without having to use Wi-Fi. It just uses its own protocol. So that'll allow me to set up a wireless connection between the handheld controller that I'll have with a joystick, so that it can send commands back to this ESP32, which will then control the motors based on whatever commands it receives from the handheld controller. This is the sort of the frame for the base of him. Obviously, as you can see, it's aluminum extrusion. What I did was I just got different types of aluminum extrusion and fixed them together using self-tapping screws. I was surprised at how hard it was. Like I drilled out pilot holes before putting the screws in. And even at that, the self-tapping screws, it was really hard to get through the aluminum. I don't know why. It took a long time. Like I would sit there and drill and drill and drill, and it felt like nothing was happening. So I'm not sure if you're not supposed to use those on aluminum, but I don't think so. Anyway, I mean, I got them to work, but they didn't go in easily. I thought about rivets, but I didn't happen to know where my rivet gun was at the time, so it was just as easy to grab some self-tapping screws. I custom printed this saddle for the batteries. I custom printed this mount for the ESP32. There also will be, I forget the name of the little board, but there's a little MP3 player board, that PCB that you can get, that a friend of mine just gave me one. He had some spares. So that'll allow me to trigger, using the ESP32, I'll be able to trigger files off a little SD card. So it'll be able to play, voice snippets from K9. So he'll be able to come up to you and say, "Danger, doctor," and maybe I don't know. I don't think it'd be a problem to put the Doctor Who theme on there. I'm sure no one's going to be too concerned about copyright just for that purpose. It's not like I'm, trying to reproduce these on a regular basis and sell them. That's obviously a copyright issue. This I don't like. So the servo cable that runs from the motor controller back here, which will go up to the control signals from the MCU. I've got to get a longer one because this one has a connector, and I don't want any splicing of wires sort of hidden away, right? I just want a direct connection from point to point. Otherwise, these can become potential failure points. They get loose, the thermal creep, and then they lose their connection, and I don't want that happening because it wouldn't be fun for some person to have to try and troubleshoot a project that they didn't design and they don't have, thorough documentation for, or any documentation for that matter. I don't plan on doing it. So, so I'm eliminating as best I can any potential, failure points. I'm using wire ferrules everywhere. For example, wherever I connect into a screw terminal, a lot of people just sort of strip the end of the wire, give it a twist, and then put it in the terminal. That's not correct. You're supposed to use ferrules, and if you don't use ferrules, they'll come loose eventually. Technically, they'll probably eventually come loose even with ferrules, but with ferrules, that's how they're designed to be used, and they will last a long time. So I'm applying wire ferrules to all the connections, or all the ends of the wires before that's why the ESP32, I bought a breakout board for it because it comes with these, I would have thought that soldering them directly in some way would be the best way to connect them. But in my experience, what happens is that's actually when you try and solder a wire directly to a PCB, it ends up snapping. That the point where it connects becomes a flexing point, and the wire fatigues and breaks off. So that's why I've decided that wire ferrules into screw terminals is the best option for this project. The batteries. The batteries. I think I mentioned they just charge using a regular standard charger, which obviously will come with K9 when you buy them if you do. But that's where we are so far. Got a lot to go, but I've got 4 weeks. So, obviously I've got other things to do in those 4 weeks. I'm not working on them full time, that's for sure. But I'm going to dedicate as much time as I can because I need to in order to finish this. So that's where we are. So in 1 week, hopefully I'll be able to show you maybe some motion. Maybe I'll have at least a drive motor connected. The wheels, I'm just going to design and print them myself. I'm going to print them out of probably PETG because I want it to be a little bit stronger. And then I'll print some TPU tires that connect to them somehow. I'll set them so that they sort of physically, mechanically snap on or something like that, so that they have some grip for the ground. I think I'll leave it at that. That really covers everything so far. So yeah, so I'll see you in a week, and hopefully our buddy will be looking a little more like the real thing at that time. Thanks, guys. Take care.